Hello everyone, my name is Sakuma of Tsukuba University. Today's topic is about the toward realization of trustworthy AI. First of all, I would like to touch on the AI itself. AI has the two phases, training and testing. First, in the training phase, the learning algorithm will be given the training data and to have the model for prediction. And in the test phase, in that model, other data will be fed and the new prediction will be acquired. For instance, in an image or a task of recognizing an image is a good benchmark problem for AI. On the right-hand top image, what are these pictures? So that is the image recognition task for AI. On the left-hand graph is what was the error rate that AI managed to recognize the object. In 2010, error rate of the object recognition was 28%. Later, deep learning technology rapidly expanded and this no error rate dramatically reduced. For humans, error rate for the object recognition is said to be around 5%. In 2015, AI already surpassed or excelled humans' recognition and then already reached 3.6% level, and later continued to improve the error rate of AI and then already surpassing the humans' recognition capability. As you see, AI recognition of the ability to make judgment is continue to be improving. Eventually, AI will replace human experts. For example, the diagnosis by physicians will be replaced by AI, or driving car by human at the moment will be replaced by AI. Those are the possibilities. And 100% replacing humans' work to be AI may not be realistic, but the part of the expert work will be replaced by AI, so that alleviating the expert burden, that is the possible promising area. As we see evolution in this AI, letting AI to do the expert work, which criteria must be met to rely on AI? On the left, you can see the numeric image. Traditional classical AI using the task for numeric classification task and identify their performance. And compared to that, letting AI to do the expert work, they have to handle more complicated and challenging tasks. For instance, as you can see, this is a medical diagnostic image task. So compared to this simplified classification challenge to the very severe and seriously affecting humans' life or death to be done by AI, very different type of evaluation is required. So AI's judgment just not being correct, they have to have a good logic, sufficient logic for explanation and ethical enough. And the trustworthy AI, to be realized, there are certain conditions. Minimum required conditions are the quality level of judgment must be in line with expert level, and also the judgment complies with the laws and regulations. Those are the prerequisites. Other than those, to replace expert work by AI, there are so many other conditions related to reliance or reliability. One is the stability against safety. Normally, AI will be driven in the computer systems. The systems, including AI, will be deployed in the real world society. The environment is different compared to the lab, so some there might be someone trying to cash in on using AI or someone intending to create havoc in a society. Such kind of a hostile entity may influence AI. Still, AI needs to be resilient and should not be affected and continue to perform a correct prediction and decision making. And the judgment of AI should not infringe human rights. For instance, decision made by AI may interfere someone's the privacy, or the decision made by AI will discriminate someone. That must be avoided. So the decision made by AI should not infringe human rights. Those are the conditions to configure AI. And also, the decision made by AI must be validated after the event or after the prediction. For instance, a car driven by AI may incur accident. Why AI caused such kind of accident? That root cause must be explained or explainable and must be validated later on. That system or structure must be in place. As such, reliable, trustworthy AI building is not just to achieve. There are many things to be done on top of the correct answer to be output. Today, I would like to touch on some of the areas related to those requirements. First topic is about the resilience against attack. The vulnerability of AI against attack, one good example is adversarial example type of attack. On the far left, you can see an image for a human being, naturally panda. And the AI image recognition of this image, of course, should be answered as panda. However, if the noise in the middle will be added on the left-hand image, then, as you see on the right, the image is created. Image with noise. So this noise is very subtle. Human being cannot tell the difference. Therefore, humans will recognize on the right image as panda. However, AI recognizes this image as a gibbon. The reason is that the noise in the middle will deceive AI. So this is artificial noise. As such, there's the recognition gap between human and AI that could create havoc. And such a hostile sample, not just an image, but also voice will be the target of hostile samples. And this is the image audio files, and music is one example here. And the very subtle noise or small noise is added on music. Even with the subtle noise is added, humans continue to recognize this as music. However, this will be replayed on the speaker or radio, and using with sensor like smartphone speaker or smartphone, will not recognize this as a music but a voice command. By abusing these behaviors of AI, for instance, voice command to unlock an entrance door or call an ambulance, that kind of malicious voice command can be hidden or embedded in the music to create confusion in a society, or it could trigger a crime. So these adversarial examples are causing unexpected operations for human beings. So from that perspective, these examples are quite problematic. And this signage is the stop signage, traffic signage for stop. AI recognizes signage in autonomous driving needs to stop. However, if there is an artificially created butterfly image is displayed here on the right, because of these, the butterfly image, AI misunderstand the stop sign as a speed limit. That is one example of adversarial example.
Adversarial examples could be change or twist the AI decisions by malicious people. For example, maybe pharmaceutical company may want AI to come up with a diagnosis that would help their company to sell more drugs. Another example would be the news delivery by AI. Adversarial political party may want AI to deliver news that would get their party's candidate elected. So to get AI to make high-stakes decisions that could impact the human life or death, AI should not be fooled by malicious humans. This kind of adversarial samples are actually created by AI. So what is attacking AI is AI. And for this adversarial attacks, we need a defense mechanism. And that defense mechanism is also developed as part of AI. So this kind of battle is AI versus AI. Here are the history of adversarial examples. The first adversarial example was found in 2014. Then there were adversarial training, a method that was developed to defend against such attack. So when training AI, rather than regular training data, the adversarial samples was used to train so that they will not be fooled by adversarial attacks. But that method is considered to be still effective, but the learning inefficiency and low precision could be the issues. After that, various defense methodology were developed, such as defensive distillation and detection methodology. I wouldn't go into the details, but a neural network would be protected by those methods. However, those methods were just invalidated in the following year or in the year that was developed. After that, defense mechanisms such as obfuscated gradients and certified defense were developed. However, it still haven't been done to achieve 100% defense mechanism. We can defend to some extent, but maybe the scope is limited or a different method can invalidate that defense mechanism. As you can see, the attacks by adversarial example and the defense against those would have a never-ending arms race. So we should learn from the history. So here are the lessons learned from the history of cryptography. The first cryptography was developed in the Roman Empire age called Caesar cipher, which is a very simple cryptography. So it was invalidated by very simple attack. After that, Enigma, which is a encryption using encryption device, and block cipher and RSA, various type of cryptography were developed. But those cryptographies have been invalidated in the past. And this arms race is never ending. So the history of cryptography is the battle against the cryptography and the attack. So the attack and defense side would continue to fight against each other in order to heighten our security level. So what shall we think about this deep learning and security? Deep learning performance is so high, so it's been actively researched for the past 10 years. It's an AI algorithm, and that structure is quite complex and very large scale. The prediction performance is so high, but it's too complicated, and it's like a spaghetti code. So if it's too complicated, it would be easy to attack, but it's hard to defend. The deep learning research started 10 years ago. So the cryptography technology to guarantee communication has not yet attained for 1,000 years. So to achieve perfect guarantee of decision making would be quite difficult. So we cannot achieve a perfect safety immediately, but by continuing the attack and defense, we can gradually achieve safe deep learning. Next, I would like to talk about fairness achievement by AI. So AI decision making would impact human lives. For example, AI might make decisions of hiring, or maybe it would conduct credit scoring, or AI would decide pass or fail of school admission, or AI might does the insurance rating. In this kind of settings that would impact human life in a great deal, there could be a possibility of discrimination by AI. For example, when AI makes hiring decision, and if AI hires more men than women, that means AI has gender discrimination. This is an actual example of discrimination by AI. This is a discrimination in search advertising. If you search by African descent name, then the search result shows the history of arrest of African descent people. And if you search by European descent name, the search result shows the location of those people of European descent name. That means AI has discrimination against African descent people. So that paper was presented in 2013. So AI as algorithm to show search advertising had some discrimination. Also, this is the compass, which is used in the US court, and a compass assesses a potential risk of recidivism. In American court, depending on the race and age and the history of crimes, compass assesses the potential risk of recidivism. then there was a possibility of racial discrimination. The person on the right was assessed by Compass as a high score. However, in reality, there was no recidivism. However, the person on the left was assessed by Compass as low score for recidivism, but in reality, he was arrested 3 times after he was released from the jail. So this was just one example, but statistically, when we evaluated this, the African descent people had high recidivism, but that recidivism rate was actually low. And on the other hand, the white people were assessed low, but the recidivism rate was high.
Therefore, Compass, in terms of the recidivism score prediction, includes the discriminatory element. Why AI contains such kind of unfairness? There are many reasons behind, but there are basically 2 big elements or reasons. First is a bias due to in the data collection. For instance, the past record of hiring to learn hire, non-hire model and make AI learn such a model on decision making of hiring. In that, in past record of a human hiring personnel give this data. So that when this no hiring personnel did the discriminatory decision making in hiring, then that AI given such database would continue to have the decision of the based on the discrimination. That's called unfair labeling. And another example is that the loan decision will be done by AI, but data sample given to AI by a staff in charge of loan decision may have been pre-selected to cover people who are eligible for a loan. So that means AI learned with data only people who had a track record of the having loan. So when AI will have the prediction for the people who have never got the loan, then the AI may have the answer of the discriminatory decision. So this is the bias with sample data. And another cause of that unfairness is a bias in modeling. In the machine learning, which is the technical base of AI, minimize expectation of prediction error. That is the basic principle. And in this expectation, the minority will be ignored. Even not ignored, but underestimated. If so, within the given group of people with the minor attributes, they were underestimated. That's the reason for the AI to tend to have the discrimination against minorities. Those are the points raised so far for the discriminatory AI decisions. Then how can we make AI more fair? To do so, fairness measure indicator would be employed. To do so, to have those measure, AI can be more fair. And one fairness measure example, demographic parity. So demographic parity is that the decision making against certain attributes. On the left, the male gender, and that male was at the time of the hiring interview, the person was hired or not, and this ratio is shown. And on the right graph is a group of people or women, and hiring decision fail or pass, and that ratio is shown. In that hiring non-hiring ratio, even with the different attributes, if the ratio is the same, then it is fair to identify that gender inequality does not exist. That is the demographic parity. And if this ratio gap is large, then it means the more discriminatory. So using this demographic parity, AI can learn fair decision. And AI make the certain decisions. If there is more imparity or unfairness, then some penalty will be given. By so doing, gradually, AI will make the more fair decisions. Certain level of unfairness will be reduced in such technology. It has been developed in many ways, but there are so many other problems to be solved. For example, the demographic parity is one element to achieve fairness, but other than demographic parities, there are many other definition of fairness, because it depends on people to define fairness. So in order to make AI more fair or let them learn on fairness, we have to set certain criteria, and that is still under study. And the decision-making discrimination by AI depends on certain specific attributes or not. That is the basic principle. However, the data set to be used by AI may not necessarily cover the attributes that drive such discrimination. For instance, in order to prevent the human race, some data may not necessarily have the race attributes, or in some countries categorically ban to gather such kind of race data. And in that case, whether the decision of AI triggered the discrimination or not, this decision for such would be difficult, and prevention is even much difficult. This is unsolved open issue. And to achieve the fairness and the better prediction will not be compatible. If so, in order to achieve fairness, the performance of prediction by AI may be sacrificed. Therefore, to achieve fairness, what kind of cost can be paid? It is a big, challenging question. So this is not the framework of computer science, but it is the social choice decision. Therefore, when AI is deployed in society, possible problems like that may not be solved within the scope of computer science. To solve those issues, not just the computer scientists, but the social scientists as well, and other type of expert knowledge must be employed. Finally, I want to talk about the explainable AI. Recognition process by AI may be different from that process of human being. There are some examples shown. On the left-hand top, this is the result of AI, image recognition. On the far left, President Obama tried to throw a rugby ball, but the AI recognized this as a basketball. Why they misunderstood it's rather difficult to explain, or to grasp. But in fact, the basketball players have many background are African Americans, and that's why the object was a rugby ball. But looking at the skin color of President Obama, AI may have judged as a basketball. This may be a judgment of discrimination, possibly. And in the middle example, AI recognized this image as a ping pong ball. And this has the national flag of China and the Premier Xi Jinping. And there is no element of ping pong ball, but some kind of misunderstanding was associated with this misjudgment. And at the left-hand bottom, you can see the texture image of a skin of an elephant. So this image is shown to AI. AI responds as an Indian elephant. And in the middle image is shown AI respond tabby cat. And on the right, you can see the image combining the two. Form is a cat, but the texture is Indian elephant. AI respond as the Indian elephant. This tale explains that the AI does not recognize objects by looking at the overall shape, but by only a localized texture.
The right-hand side image. The left one is the original image, and the ones on the right are the texturized images. Humans cannot really recognize what the image is about when it is texturized, but AI can continue to recognize images correctly even with texturized images. So this is also the proof that AI recognize not from the overall image, but looking at the local part of the image. So the process of AI's image recognition is quite different from that of human. This is called Activation Atlas. And we try to understand which clues AI uses to recognize image. So those fragments of image is shown to AI, and we would like to understand what clues AI is using to recognize the image, but it is quite difficult to do. The recognition process of neural network is not necessarily clearly explained, so it's a black box. So we want to give explanation to such black box, so various measures have taken, and one of that is attention mechanism. With attention mechanism, in order for AI to give decision making, some part is viewed by AI, and that part is highlighted. The left-hand side image is a woman who is throwing a frisbee in the park. As the caption says, a woman is throwing a frisbee in a park. The AI views the image and highlights the area where red frisbee exists. So AI looks at that red frisbee and recognizes that as a frisbee. On the right-hand side, it's an image with a dog. And when AI looks at this image and the caption, the dog part is highlighted. So with this highlight on the image, we try to give explanations to the AI recognition. So we used attention mechanism for malware analysis. The left-hand image is the binary of malware, and on the right-hand side, we give attention to that. And by looking at where the attention is high, we can understand how AI characterizes this image. So the malware is Win32 Gaubot, and it uses IRC and also intercepts HTTP FTP communication to steal login information of PayPal. So that's a characteristic of this malware. Then we looked at the code area where the attention is high. Then we understood that it's a function to connect to an IRC server, or the part that is intercepting HTTP communication to get the login information of PayPal. Like this, with attention mechanism, we can understand how AI would perceive this malware. On the other hand, is explanation given by AI reliable? This diagram shows what cues AI uses to identify numeric letter 0. So the image segment on the bottom shows the concept that AI looks at. As you can see, the image of circle is considered by AI as important concept, and that is very reasonable to identify numeric letter 0. However, it gives importance to horizontal bar as well. And if you look toward the right, red image, yellow image, and blue image were given importance as well. But colors are irrelevant to identify numeric letter. So it's not a proper explanation as number recognition. As you can see, there are some cases that we cannot trust the explanation given by AI. So to give trustworthiness to AI, we try to give explanation to AI's process, but it's still, there are many problems that have not been solved. For example, when AI recognizes something, we want to understand what cues AI uses to recognize, and we try to quantify that. But how can we prepare concepts for explanation by AI? That's one of the problems unsolved. Even human experts cannot give clear explanation of decisions sometimes. Therefore, to make AI do the same might be difficult to begin with. Also, how can we evaluate and verify the correctness of explanation by AI? That evaluation method has not been finalized yet. And how can we prove reliability of explanation by AI? We still haven't established a correct way yet. So to give explanation to AI, that research itself contains a lot of problems that were not solved. In today's presentation, I talked about towards the realization of trustworthy AI, what kind of requirements needs to be met. First, the necessary conditions is that the AI's prediction have to be correct, and AI decision making have to comply with the law. Those are the necessary conditions on decisions by AI. And also, when AI is put in the malicious environment, AI needs to be resilient against attack. And AI's prediction and decisions should respect human rights, and it shouldn't create discrimination. And also, the AI's decision must be explained and traced afterwards. Like this, there are many challenges left to realize a trustworthy AI. Thank you very much for your attention.